It's my pleasure to introduce the seminar speaker for today, Dr. Matt Huddelston. We've got his PhD right here. Also, former colleagues in the room, here it is. He also got his master's and bachelor's degree from Eastern Kentucky, where he's from originally. Currently he's the vice president for environmental services at Copperhead Consulting. So I know a number of you are going to have a good lunch with him, and undergraduates will get some good advice about navigating that field of job market. But with that, I'll turn it over to you, Matt. Let you introduce yourself.
Thank you. Well, thank you all for the invitation and opportunity to be here with you. By way of introduction, as Dr. Huddelston said, I'm originally from Kentucky and background in biology and aquatic biology from Eastern Kentucky University. And long about 1996, right before then, I was introduced to Dr. Don Rogers, who's the back corner of the room there, and visited him at the University of Mississippi. I was interested in environmental toxicology, pursuing my profession in environmental or ecotoxicology, which I want to focus on the wildlife part of it. And Dr. Rogers and I hit it off, and I started my doctorate there and came to Clemson in 1998 and finished here in 2001. After coming to Clemson, we had the opportunity to work down at Savannah River site on a constructed wetlands project, and tell you more about that a little bit later. But that's the bulrush part of the title here. If you looked at that and you thought, well, those three words don't fit together, that kind of represents my path in this profession. So we worked a great deal on various species of bulrushes and other aquatic plants for the purpose of cleaning up some wastewater, various sources, and had the fortunate opportunity to keep doing that later in my career. I'll show you a picture there in a second. But I did want to just say that I'm really happy and thrilled that Dr. Rogers is here. I think for him, I wouldn't be standing here talking with him today. So for that. So a little bit more. I do want to hear more about. I think we've got an opportunity to talk with you all at lunch. So I'll hear certainly about your research interest and where you are in your path. So what I'd like to do today is tell you a little bit about the profession of environmental consulting as I've experienced it. If there's all flavors, and I'd love to kind of delve into that and answer any questions that you have about what are different firms, different consulting firms like. What are their focus areas? What are the cultures like? And so I certainly want to get into that. And then I want to tell you a little bit about Copperhead specifically and some of the things that I think are interesting scientifically and professionally that we're doing. And maybe that'll pique some interest and we can have further conversation, about opportunities there. And then we'll kind of wrap up. So feel free anytime to stop me and ask questions. Happy for this to be an open conversation. So, like I said, started off here at Clemson in working in constructed wetlands down at Savannah River site. We had an opportunity to publish a couple of a series of papers in environmental geosciences, and this is called the AO1 constructed wetland system at Savannah River site. That was my dissertation focus. And then after I graduated, continued to do more work in constructed wetlands where we applied the same technology, or I should say similar technologies, to cleaning up some wastewaters associated with coal fire power plants and that kind of things. So after that, I began a career in environmental consulting. That's been 25 years ago. Hard to believe. But let's talk for a minute about about, what that profession's been like in general. As I said, consulting firms, there's all flavors. Everything from, one person can be an environmental consultant and sort of they can do it solely as their job, or they can do it on the side. Lots of times. And then the other extreme is there are consulting firms that are employ thousands of people. And in the sciences, that can also range broadly, because in your larger consulting firms, ones that are thousands of people, those are typically engineering focused firms. They design things and build things, but they know that in doing so, they have to do certain environmental due diligence, certain environmental studies, and get permits from, say, the US EPA or the Corps of Engineers or the US Fish and Wildlife Service to be able to complete their projects. And so sometimes or oftentimes those larger consulting firms will have, a smaller division that focuses on environmental work. Generally speaking, large firms can be quite corporate. They have to be, because it takes a lot of money to run big companies, and so they have to find big projects. And so they're usually pursuing large construction projects, maybe large environmental cleanup projects, and those kinds of things. And so in that kind of environment, with a lot of people, you have to have a lot of processes and procedures in place. And so to be employed by that sort of in that scenario, there's a lot of structure involved in that side of consulting. Take the other extreme, smaller consulting firms, in my experience and estimation, are a lot more nimble, if you will. And Copperhead is one of those. And so we're able to sort of plot our own destiny. We do the things that interest us, and thankfully we've got a pretty good reputation in doing that, and good relationships with folks that we work with, such that we tend to let a curiosity of the natural world and science sort of drive what we do versus the more, versus what I just described on the more corporate side of it. And then there's everything in between. So I just threw a few words, on here to try to touch on, but I think culture is one that you need to consider if you're looking at a potential career or starting a career in environmental consulting. Culture is an important one to try to take in if you're in your interviewing process. Try to get a lead on what the culture's like, and do you fit there? Because, like I said, there's all flavors. Areas of focus. I'll jump to the second one there. What I'm referring to there is sometimes, like I said, even though they're called environmental consulting firms, they may have an engineering focus, or they may have an hydrogeology focus, and then there are firms like Copperhead that have more of an ecology focus. And so they all have sort of their discipline that they tend to practice. And so again, that kind of goes back to culture. Where do you fit? I mean, or would you be comfortable being sort of the part of a small unit in an engineering focused firm, or would you rather be one of the several ecologists in a smaller firm that solely has that focus? So again, just need to see where you fit best. Any questions about that kind of thing? All right, so a little bit about the day-to-day. So how do you secure projects in consulting? It varies. There are difficult ways to do it, and there are easier ways to do it. And when I say that, often projects can be quite competitive. And so finding those projects, so if we go back to sort of that large corporate firm scenario, oftentimes you'll have marketing people. That's all they do. That's their job, is to go out and find these large construction or large cleanup projects, and they're constantly out on the road and marketing the brand and all that sort of thing. There are also a number of databases out there that put out requests for proposals and requests for qualifications for various projects. Copperhead, for example, we subscribe to a few of those. So we see a number of federal opportunities that come through with the U.S. Forest Service or the U.S. Wildlife Service, or Fish and Wildlife Service, Park Service, EPA. There's a recent one just came out. Talked with Dr. Logan just a minute ago about an EPA opportunity that we just saw that usually EPA does internally, but because of some of the changes as a result of the administration, there are things that are being, we'll say, farmed out to consultants. And so call this afternoon about that. So yeah, we track those things. There's a cynical, a bit of a cynical maybe way of looking at that. Oftentimes people say, well, if it's on a website, and it's already been decided. Somebody's already got that job, and so that's what it's about. Well, maybe not in all places, but a very effective way of securing work is to really just build relationships with your clients professionally, and just do good work, do good science, and complete projects on time as best you can, and on budget as best you can. And if things start to go awry, and you think, I don't think we're going to get this deadline, or maybe we're getting a little bit out of scope, and we need to bring it back in, then communicate. The communication with your client all along the way is critical, because lots of times you can head off any problems associated with missing deadlines or going over budget. And so, just like I said, doing good work, doing good science, and getting the word out there. Go to conferences, interface with folks from agencies and universities, and present your work at those, because that's your credibility, or at least part of your credibility. The other part is publishing, and that can be a challenge in consulting, because oftentimes it's not really part of your job, and you get busy doing other things, but if you can make the time to publish and get your work out there, get your science out there, that's the other part, I think, of your credibility as a scientist. And that seems to work really well. That's at least a good formula for Copperhead, I can say. What else? Scoping and costing, that's, I think that goes with any profession almost, is really understanding exactly what the scope of work is, what you're going to be doing, what the goal is, the objectives. Make sure you've got those down in the beginning, and then costing that. Consulting firms, large or small, are structured sort of like law firms, in that everybody has a billing rate, and your billing rate is based sort of on your where you are in the company, and your experience and your responsibilities, and so we scope things accordingly. We'll put 3 field biologists on this project, and they'll have one supervisor we'll put a principal, to kind of oversee that. Principal usually only has a few hours maybe to make sure everything's going well. And the field folks, they get the job done on the ground, and then you've got, sort of that manager in between and make sure it all gets done correctly. And then you all come together and wrap it up with a report. It goes out, and sometimes there's a review by the client, and it comes back and fix it, or whatever you need to do, but you're done, and on to the next. And so those can range, and from small projects that just take a few weeks to a couple of months to a few years, wide ranging. Role and responsibilities, that I kind of hit on that just a second ago. Coming out of a graduate program, you're typically going to have a bit of a higher expectation versus coming out of an undergraduate program, in terms of your responsibilities. You're supposed to know something about science, at this point, and so it serves well. It serves you well. The advanced degrees certainly serve you well in consulting. It can accelerate your career path in a lot of ways, and those expectations and responsibilities to sort of grow with your experience. Responsibilities that can, I think, as I'm referring there mainly to, not only do you have responsibility of doing good work in the field, doing good work in the laboratory, doing a good job at writing, all those things that kind of come along with a science career. But at some point in a consulting firm, you're going to get to the point where you need to manage people. You need to manage the folks that where you were maybe 5 years ago. You've always got those folks coming in. So there's some people management part of it, and then ultimately, there's if you're developing those relationships over your career with clients, then there's some responsibility for working with those folks and doing what they call business development or relationship management, and helping to find the new projects. That just sort of comes along. That's a natural evolution, I think, of your career path. And advancement, if you're doing all those things I just mentioned, you're certainly advancing in the firm and in your career. So any questions there? That's kind of a broad brush of how consulting firms can work. All right, so let's transition over to Copperhead. So Copperhead is just over 20 years old. We began with one person, a fellow named Mark Thumbert, who was a bat biologist out of Eastern Kentucky University, and Mark worked for one of the local utilities for a while as a field biologist, and then they made some changes, and Mark found himself without a job, and after some soul searching, he had an opportunity with the Kentucky Fish and Wildlife Agency and U.S. Fish and Wildlife Service to continue some bat work. So he took those projects on himself, and then he got busy enough that he needed another person, so he hired one person, and then he shortly after that hired another. And Copperhead thrived for about 10 of those 20 years as solely a bat firm, and then they decided to diversify and start looking at other opportunities and other areas of terrestrial ecology, areas of aquatic ecology, and started hiring folks with those disciplines. And here we are, over 20 years later, and our core services, I'll mention those, are that terrestrial ecology, aquatic ecology, and then a handful of other things that I'll mention in a second. We've got about we're right at about 45 full-time people. About 30 of those are in Kentucky, either in our Pink Lick headquarters or in Lexington. And then the rest of us are scattered around. I'm here in Clemson. I have a colleague in Greenville, a couple of folks in Asheville, where we have an office. We have an office in Nashville, Tennessee. I can look at the states and remember, right? Virginia, West Virginia, Pennsylvania. And so we're kind of scattered around the east, but we got a couple of folks, one's out in Colorado, outside of Denver. And recently we set up a small office in Utah. The folks out west work a lot with the Bureau of Land Management, some with the Forest Service, but got some contracts with BLM that they help out with. So yeah, so on the aquatic ecology side, we, like I said, we do a lot of work with the state wildlife agencies, work with U.S. Fish and Wildlife Service. So a lot of that is associated with the Endangered Species Act. We have a number of biologists with expertise in mussels, fish, especially protected fish, water quality surveys, backward vertebrates. We've got a team of 3-4 people actually that do wetland and stream delineations, and then help folks prepare applications for permits. In other words, that's the permit that the Army Corps of Engineers issues to people or folks that need to develop where there might be an impact on streams and wetlands, where those streams and wetlands may need to be filled in because of construction, or you're putting a new bridge over a stream and you need to relocate some mussels, but you also have to get a full permit to disturb the stream banks. Various reasons, but we will do those delineations and help folks to obtain those permits from the Army Corps. We do a little bit of watershed planning as well. On the terrestrial side, again, being a bat firm, about half of our business is still bat related. But the other half of these other disciplines I mentioned, so because we have a number of protected bats in the country, that's still a big part of our work. So we'll do presence absence surveys, acoustic calls. These are bat studies, bat acoustic manual vetting, baseline inventory, aerial telemetry. We've got a couple of airplanes. We track bat migration, mainly in the eastern U.S., some in the west. So we do a fair amount of telemetry work on bats as they migrate out of hibernation, where they're going, in their spring roost habitat. So and then other services related to birds. We do a number of raptor surveys, again from the air. Complete those for various projects. A lot like renewable energy projects, solar fields, wind, although wind's down now in terms of an energy development, but there's still a fair amount of solar, and so solar developments often require avian surveys, eagle nest surveys, for example. We'll do those from the air in combination with from the ground. We also have folks that do reptiles and amphibians, some pollinator work with the Forest Service and botanical surveys in national forests. So a variety there of terrestrial ecology. And then sort of wrapping it up, we have a team that focuses on National Environmental Policy Act or NEPA documentation. That's the process where if you're using federal funds for any sort of project, say a bridge development or pipeline that's going across a national forest, all kinds of scenarios where you might use federal funding to do that project that requires things like environmental impact statements, environmental assessments, biological assessments, and so we do that documentation. Permitting, I mentioned, like for wetlands and streams and for other protected species. Mitigation, I mentioned that this photograph is something I say it happened before I was at Copperhead, but this is called Grandin bark. And this is an artificial bark. It's a rubberized bark that you can wrap around a telephone pole, say, and create roost habitat in that space between the pole and the. And that's a form of mitigating if you're going to have to remove forest where there are roosting bats. This is one example of mitigation for that forest removal, for example. And we actually patented that. Got the idea from I think movie studios. The trees you see in movies aren't actually real. So that's where the bark idea came from. Got a number of folks that do geospatial data analysis, GIS work, and then ecotoxicology. I'll put that on the had to get my own plug in there. And I'm going to kind of wrap things up, pulling together the other two parts of the title, and that is the bats, ecotoxicology. So that's why that's there. Okay, now I'm going to shift to a couple of Copperhead projects that are kind of typical of what we do, just kind of give you a flavor of that. But before I do that, any questions? Yes.
I'm curious about the permitting process, working with endangered species. How do you, it can take a long time to get those, but do you have a system to make that as efficient as possible or an agreement with the sponsors to speed that along?
I think the system is just encouraging them to engage with the field office, geospatial field office, and the state office or agency as soon as possible, early in the project. I think I know that's sort of informal, but that's what we encourage, and usually they're receptive in doing so. Yeah, thanks. Okay, so this is a project we did with the Park Service in West Virginia, and this is a mussel survey. It included the New River Gorge, the Gauley River National Recreation Area, the Bluestone River. And so this was a pretty extensive mussel survey. We surveyed 63 sites between the three river systems. A couple of different survey methods. It kind of depended on the density of the mussels that were initially observed. Started off with sort of a qualitative time search, so you'll take a specified area and survey that area either snorkeling or by scuba. So you're on the bottom and surveying those areas. If density was greater than one mussel per square meter, then the timed survey becomes a little inefficient, and so you can kind of switch to this semi-quantitative transect method. But the purpose here is to identify the diversity of mussels in these systems, and the purpose for that is one, to identify areas that may need conservation, may need some attention. But another purpose, I think, that the Park Service was needed was that because we are using national parks more and more often, which is a great thing, having access to the river and putting in things like boat ramps, they needed to understand the mussel population so that they could minimize impact from maintenance activities and boat ramps. Thanks. Just for an example, I think this was the great. So the New River had the greatest number of mussels and number of species. The Gauley was a little bit less than that, maybe half or Yeah, made up most of the rest, and then the bluestone, turned out, I think they only found maybe two muscles, in that survey here. So there was a clear, degradation of habitat, in the bluestone that was uncovered, if you will, from this mussel survey. So that's getting attention as a result. Few pictures just to give you an idea. Of course, we accessed these sites, by water primarily, so not a bad day at work. Needs. Here's a couple of my colleagues, Price and Shay, working up the data. Those are bucket mussels, if you're interested. Most of them are. We found we catalog their feces, their size, habitat, characterization. If current was enough, but there's an example of maybe doing the transect method. But basically you're on the bottom watching for mussels. All right. So that's typical mussel bottom. We also get, as I said, we do a significant amount of that work from tracking migration to doing population studies. There's an example. We work with the Fish and Wildlife Service in Kentucky State Agency, and we do winter bat and hibernation census counts in the cave and karst areas of Kentucky. So I've got a few pictures of that. Do this annually. Those data go to the state agency as well as Fish and Wildlife Service. And we do it not only to just document how populations are doing, but a lot of this is driven by white nose syndrome, which if you're familiar with white nose syndrome and its the impact that it's had on bat populations and especially protected bats. And so that's the reason for this work. Pictures here. These are this typical gray bat hibernation in a cave. Gray bats in flight. I guess they learn that they don't completely go to sleep. They'll still move around in the caves, as many of you know, during hibernation. Yeah. These are either Indiana bats, Miles species. This is an endangered species. Grays are endangered as well. So, cluster of Indianas. Has anybody done bat counts? Caves? Yeah, a lot of them.
Katie did one last week.
All right. What kind of method did you?
We took flashlights and counted them as we walked down the cave.
So just a manual count.
Yep, yep, for tricolor.
For tricolor?
Yeah.
So if there are clusters that are too many to manually count, what are some of the other processes? Or have you employed any others? I asked one of my colleagues this the other day because I was curious.
I'm not a bat person.
That's fine. Well, from what I learned, you can take photographs, then count from photos. He explained to me too. He said you kind of put your hand up and see how many your hand covers, and then see how many hands fit into that cluster. A little less accurate, obviously. But he also said that sometimes we'll hoist up a quadrat now specified area. From what I was just curious about various methods. A couple of Indiana's close. These are big ear bats, yes, right? Couple big ears. Here's a tricolored example of white nose syndrome on a tricolor. Tricolored is proposed for listing as endangered currently. All right, that's an example of winter hibernation census counts that we do. Like I said, we do a number of other things, from habitat assessments, roost tree assessments, migrations, all things bats. Oh, a couple other things. Yeah, so getting in and out of caves and other bat hibernation areas can be tricky. This is a mine. It's actually a silica mine. Here we're collecting wing punch samples for genetic analysis to see how populations are changing in that habitat. And like I said, you get to go into some pretty interesting places. And here's an example of this is a former sinkhole. It opens up, collapses. That's why you see a mound of debris at the bottom here. That becomes then what they call a carpet window. When I first looked at this, I thought, well, I could probably squeeze through there. It turns out that's a lot bigger than you think. So we do a lot of road work to access these bad carbonation habitats. So we've got some folks on staff that expert repellers and road work folks that train the rest of us, but that's oftentimes how these are accessed. It's not exclusive to caves, of course. We'll do cliff line surveys by repelling, and then as you know, bridges can be a popular place for bat roosts and habitat. So doing that by repelling is also generally the most efficient. And then things can also get tight, right? So a little bit of that. All right, I'm going to transition here. Any questions about how we doing on the top? Good. Let's say we'll wrap up here in just a minute. So I'm going to shift over now to this is the benzene part of the title. Been working with the Federal Aviation Administration for a few years now to help them replace leaded avgas, it's called, or 100 low lead, which is a typical fuel that piston-driven or propeller airplanes burn. So back in the 1980s, when the EPA phased leaded gasoline out of automobiles, they did not do that for what they call off-road vehicles. It turns out airplanes are off-road vehicles. The propeller plane are. And so the general aviation, which refers to piston-driven aircraft, still preferred leaded fuel. Well, a few years ago, a lawsuit was filed against EPA for not phasing leaded fuel out of aviation because it found some lead contamination around regional smaller airports, and is the basis for that lawsuit. And then the EPA then turned to the FAA and said, okay, find an alternative. Well, had the opportunity then to come in with the FAA and help them in sort of their toxicological assessment of these candidate fuels that would eventually replace 100 low lead. It was a it was a multifaceted project. I mean, you had to look at all aspects of replacing the fuel, everything from developing the fuel, transporting the fuel, storing the fuel, how the fuel behaves once it's in the engine, what's its flight performance, across the board. So I just had a small piece, we had a small piece in terms of the environmental toxicology part of that. But, and this is one of our Copperhead colleagues here, part of their that migration work. But, a little bit about that. So we embarked on, as I said, replacing leaded aviation fuel. Rather than at the initial phase, rather than to test fuels in the laboratory, with various, aquatic or terrestrial species, and actually develop toxicological benchmarks for those. That may happen eventually, but right now, we're relying on peer-reviewed literature, technical reports, and understanding basically what the toxicological effects are on the components of the fuel. So we're not testing the so let's fuel X may be made up of acetylene and gasoline and ethyl tertiary butyl ether. Three main components. And so there's enough information out there about each of those components that you can rely on the literature primarily to sort of work up a toxicological profile based on the literature. If that makes sense. So that's where we are sort of as in this initial phase. And again, with the goal to transition over to non-leaded fuel. Just a couple of examples of where we are in preliminary findings. These are some examples of, well, here's the take home. Leaded fuel, which contains tetraethyl lead, is a quite toxic compound. And we also add to that fuel ethylene dibromide that helps what they call scavenge the lead when the fuel combusts in the engine. Both of these, it turns out, are more toxic so far from what we've looked at, more toxic than the components that we're seeing in the new fuels, the candidate fuels. And so there's a clear pattern of 100 low lead, having much greater impact on ecological sources or wildlife and ecosystems than these candidate fuels. And same for human health. But just as an example, if you look at a toxicity level like the 96-hour LC50 for tetraethyl lead, 1.4 milligrams per liter, when you compare that to a typical compound in some of the newer candidate fuels, it's greater toxicity value, which means less toxin. So again, the new candidate fuels are more, they don't contain lead, and so their degradation, typically their behavior in the environment, is safer because without the lead, which does bioaccumulate in ecosystems, these organic compounds that make up most of these newer candidate fuels don't do that. So we're seeing a safer profile with these candidate fuels. And that's really just what I just went through was preliminary findings. What we're doing is, or where this stands is there's a second phase. It turns out that the 4 or so fuels that we evaluated in the first phase didn't behave so well in the engine tests. And so they were scrubbed, or at least asked to go back to the drawing board and make some tweaks. And so the companies out there are doing that now, and we're about to start a second phase, hopefully this year. All right, so bringing some of this together. I've mentioned ecological risk assessment. That's a tool that environmental toxicologists, ecotoxicologists use to evaluate the potential impacts that environmental stressors such as chemicals, could also be disease, could be habitat loss, invasive species. But it's a prescribed process of understanding what those impacts can be. And that's something that I do and have done throughout my profession. And this is kind of the framework of how you do that. You start with defining the problem, and then you characterize the exposure. You understand, okay, what are the chemicals that wildlife are being exposed to, wildlife and plants, your ecological receptors, call it. What are they being exposed to, at what levels, in what forms? And then on the other side, then you go to the literature generally, where you develop these toxicological benchmarks to compare the exposure and the potential response. And if the exposure exceeds the response, right, then you've got some work to do. There's a potential risk to that ecosystem. And that's called the risk characterization part of it. And oftentimes you do that mathematically with what they call a hazard quotient, where this is the exposure characterization piece of it. You develop or you find relevant toxicity benchmarks out there. You compare those two, that ratio, and that gives you a number. If you're greater than 1, then there's a potential risk. If you're less than 1, there's no indication of risk. So to get to this piece of it, that requires estimating an exposure concentration or a dose. Let's take, for example, a shrew, and we've got a contaminated site, and we're going to use a shrew for one of our ecological receptors. And so we have to understand, we have to characterize the contamination. What chemicals are we talking about? Where are they? How are they distributed? And then how are they getting into the shrew? And so what's the shrew's dose of that chemical? That's the question. And that dose is going to depend on how much time the shrew spends at that contaminated site. It's going to depend on a number of their physiological characteristics. What do they eat? How often do they eat? How much do they eat? Do they drink? Where do they, and where do they drink relative to contamination? So all this goes into a soup of calculating the dose. And so these are I just mentioned life history parameters that kind of go into this dose calculation. And like things like body weight, ingestion rates, time that they spend, what their habitat size is relative to the contaminated site, how often are they there, all the time, maybe they're just passing through. It all goes into this dose. Well, the EPA compiled several years ago this in the Wildlife Exposure Factors Handbook, that information for a number of ecological receptors or wildlife. And this is a snapshot of just the mammals that you've got to choose from. And so if you've got a contaminated site, you have the opportunity to say, well, if I'm in upstate South Carolina, I'm not going to choose a harbor seal, obviously, but I can choose the ones that are probably representative of my site. And I'll use those models, those animals, those receptors to calculate those hazard quotients. That's how it works. Well, being part of the firm that sort of specializes in bats, we recognize that we may be missing some opportunities here, because oftentimes bats are not included, or they're not on this list, which means they're not in the wildlife exposure factor. But given their ecological critical niche, I think we have an opportunity and should, in many cases, at least consider bats as a potential receptor when we're looking at at environmental cleanup. And so, again, there's an opportunity here, and I'm collaborating with my BAT colleagues that have a lot of, this information to pull from, and we're going to see if we can develop that ecological risk model for bats, so that we can hopefully make an impact on protecting some of our listed bats that are certainly worth protecting. Got a couple of proposals out to do that right now. So I think I'm done. Thank you all. Yes.
Really interested in the monitoring projects that you have going on. I know it takes a lot of time and effort to even do like the fieldwork aspect of that. I'm curious if, how much time is there for the analysis side of things on the back end beyond, population numbers, which is a very important contribution, but yeah.
You mean like the data analysis
Yes,
piece of it? We'll build that in certainly to projects, and I'd say on the order of weeks. Usually, a short turnaround, I think, for a report, which would be based on the data analysis, is probably 2 to 3 months. I mean, it's going to vary based on the size and scope of the project, but that's built in to the scope, built into the budget, and I would say it could range from a couple of months to, in some cases, several months, up to a year. Yeah.
I'm gonna piggyback off Allison's. So you mentioned like publishing. How do you negotiate data ownership and the ability to publish a study on some of these projects that are probably, in places that maybe people wouldn't necessarily want that data out there?
Yeah.
And do you negotiate that when you start the project, or is that sort of a back end conversation?
Yes. When you start the project is a great time to do it. Not that at some point it doesn't occur to you that, hey, this is really interesting. Maybe we should talk to the client and see if there would be, if it were to everyone's benefit to publish this. That does happen, but usually that's up front. And oftentimes, especially if you're working with federal agencies or state agencies, they recognize that up front and say, hey, let's build that into the process.
Kind of also related to those questions, I was curious, since you talked about both fieldwork and lab work and writing and data analysis, like what would you kind of say like the proportion of each part is in your like day-to-day?
Oh, wow. Good question. The lab work and reporting and especially if it involves acquiring a permit, usually takes the longest, especially that permit actually, because you're preparing a permit application that goes to the Fish and Wildlife Service or the Corps of Engineers, for example, and there it kind of go. You don't know where it's going. Well, you know where it goes, but you don't know how long necessarily that's going to take. So that's usually the long. So the field portion is usually the shortest. Data analysis is probably greater than the timeline for your field work, but then permitting really gets you into that longer period. Okay.
Does everyone take part in like the RFP process, or do you have specific people that kind of manage
Yeah,
this?
good question. Not everyone, but that's not because they're not invited to be. Not everybody likes. Usually that falls to your project managers, your folks that are responsible for managing projects and even on up to to principal level. We usually develop the reports, but for the most part, it's your project managers. And when I say project managers, it's people that have probably been in their role for, let's say, 5 to 10 years, work their way into understanding those relationships and what proposals need to look like and how to scope, cost them, so that you're doing things, you're completing the tasks on time and on budget, and they just have a better sense of that. And so because of that, folks that are new to the organization generally don't contribute to that. But what happens is most often is folks start to express interest in doing that. They've been around a couple of years, and they say, you know what, I love working in the field, but I'd like to learn how you do this. And then it's okay, well, come on in.
Do you ever feel pressure from a client to reach a certain conclusion, and like how would you combat that? I'm assuming it happens, right?
Yeah, it happens. Fortunately, that's not happened to me personally many times in my career, but it does happen. It comes down to committing yourself, committing your firm's mission and integrity to good science, and just saying no, we're not going to do that. We're going to let the science speak for itself. And I think there are likely organizations out there that don't have that position. They may be more driven by other influences, but for the most part, it really comes down to the integrity of the leadership and the organization overall.
Yeah, with the current kind of administration downsizing with federal agencies and hiring freezes, are you seeing an influx in business or projects coming your way? Calls?
That's a good question. I would characterize it currently as a difference, not necessarily an influence. We have seen certain opportunities slow down. We're not seeing as much come out of, for example, the Fish and Wildlife Service or our service. But that's being replaced by, I mentioned the EPA just a little while ago, being replaced by which I think is a direct result of downsizing and refocusing of that agency. Bureau of Land Management is another example of it has increased because they're undergoing a number of proposed rule changes related to managing public lands. And so they're outsourcing getting these, collecting public comments on BLM decisions, and sort through those comments, summarize them, help prepare that announcement to go into the federal register against the rule change. So it's changed. Some things have slowed down, but it's been replaced by others.
Any other questions from Matt? Okay, we'll let him go. Let's give him one round of applause. Thank you.
You signed up for launching that.
Yeah.